Welcome to Spring LIB.
So in this problem, we are looking for the angular acceleration from B and the revolutions that B makes. The knowns of this problem are the following. We know that the initial velocity of the outside of the drums, because this is how fast the plastic film is going, is 2 feet per second. U1 is 4 feet per second. That's the final velocity. We have the radius of A, which is 9 inches or 0.75 feet. Our B is 15 inches, the radius of drum B, which is also 1.25 feet. And we also know that the interval in which this occurs is 4 seconds. So let's start off with problem A. We're looking for the angular acceleration of drum B. Well, we can just take the change in the angular velocity over the change in time. We know the change in time is 4 seconds, and all we need to know is we need to know the change in angular velocity. Well, we know that W1 is equal to V1, and in this case, since it's drum B, it's going to be over RB. We know V1 is 4, and RB is 1.25 feet. So therefore, this gives us 3.2. This gives us 3.2 radians per second. And we can do the same thing with this one, W0, V0 over RB. In this case, 2 over 1.25 is 1.6 radians per second. And from here, we can find that delta W is W1 minus W0. 3.2 minus 1.6, that's 1.6 radians per second. Sorry, per second. And so now we have the angular acceleration of B is equal to delta W over delta T. And we know that this is 1.6 radians per second over 4 seconds, which in this case, that is equal to 0.4 radians per second squared. And that is our answer. So part B, we're looking for the amount of revolutions that drum B makes. What we can do in this case is we can say that the amount of radians is equal to the initial angular velocity times time, delta T, plus 1/2 times the angular acceleration of B times time squared. This is very similar to the kinematic expression. We know that W naught is 1.6. We know that time is 4. We know that the angular acceleration of drum B is 0.4. So we can put all those numbers together and we get 9.6 radians. Great, but we're not looking for radians, we're looking for revolutions. What we can do in order to turn radians into revolutions is we can just convert it. 9.6 radians, and with the dimensional analysis, we know that there are 2 pi radians in 1 revolution. 9.6 divided by 2 pi is 1.528 revolutions. And that's how many revolutions B makes in the 4-second interval.